all, you can play on the structure you will obtain. So you can add different compound in the gel to manage about the elasticity, about the softness, about the sticking, about the hardness, about the swelling.
You are listening to Brice Diochon from SNF, France. In today's episode of Concrete Injection Made Easy, everything you ever wanted to know about acrylic gels but were afraid to ask. Make sure you hit subscribe if you haven't already and sit back listening. Hello everyone, today we have the special guest from France, Brice Diochon, who is an expert in acrylic gels, and previous episode was about how to seal the expansion joint, and we were discussing this with another expert of the injection. But today I wanted to focus on this part of what is the acrylic gel. We all use it almost every day for years, but what's inside this that we buy? How do we know that this is the material that is going to be used for water tightening our structures? So our guest, Brice, is an expert on this. First question, what's the acrylic gel in general? Can you dive into these details for us a little bit?
Yeah, first of all, hello everyone. I will try to answer all questions about acrylic. Okay, just to introduce a little bit myself, my background is a chemical engineer, and I work on formulating this kind of products, developing this and commercializing the products. So to introduce,
this is the perfect guy for this question. Yeah, I knew that. Yeah, please go on.
To answer your question, first of all, acrylic gel come from acrylic acids so it's a monomer, comes from the oil. Then acrylic acid, we make a little bit of neutralization and formulation on that, adding some product to structure the monomer in terms of let's say 3-dimension geometry when you react the gel. And adding those compounds in the formulation, you will have a complete network once you start polymerizing it. Because when you deal with acrylic gel, you start from a monomer, and then you blend some other compounds like the accelerators, like the catalyst, to really build the polymer, adding monomers together. So you can imagine a chain.
Okay.
And you can put the connection in the chain to structure the chain and to be able to do whatever you want with the chain. And you can control how fast you will assemble the chain, you will structure the chain. So that's what is schematically acrylic gel.
Okay. And then we have different kinds of gel, like I, as an applicator, use at least like 5 or maybe even 6 brands of different acrylic gels, and then there are different amount of components we can mix to achieve a certain given resin. And then we have these gels that come with the component B is mainly water. Can you discuss where these differences come from and why water? Because this is for water tightening. So why do we use water to water tight the structure?
Okay. First of all, you have different range of acrylic resin. If we focus on the acrylic, the A components, because as I told before, you can play on the structure you will obtain. So you can add different compound in the gel to manage about the elasticity, about the softness, about the sticking, about the hardness, about the swelling. So all these parameters, by adding some additives in the part A, in the resin, when you formulate products, you manage this and you achieve the product you need. So basically, we have infinity of products available. Then, okay, the market will let's say bring some standards to manufacturer. So more or less, all manufacturer gets the same product, get same standard. As soon as they are initiate to this technology,
they will never admit that this is more or less the same.
No,
because
of
every
course.
one of them have better stuff than the others.
Yeah, but in the fact, the components, the main components, and then the cross linker you put inside, and the other additives, okay, they have all the same chemicals function, more or less. So then that just about the active content, about the amount of cross linker, about the different ratio you put in the formulation, that make the difference. So that's why there's different formulation. So that's for the part A. Then, if we focus on the part B, normally B is the part you bring the salts, the catalyst to initiate the radicals, then to start the polymerization. You bring the salts with water because you need to dissolve the salts. So that's the first point. Then, to enhance some properties, to improve some properties, you can replace the part of water by, for instance, some cement, some kind of latex. So you can play on that. You can really also play on this B parts to achieve different properties of the final gel.
I see. So as I understood, the most important thing is happening in component A.
Yes. Yeah. The everything is starting from the A component to build the polymer, to bring the structure, and then you put some other additives possibly in the B parts if it's not enough in the A, to enhance some elasticity. For instance, if you bring some latex, you will have some elasticity. You will slow down or decrease the swelling rates. If you bring some cement, you will have a really hard finish material. So you have different possibilities. In fact, possibilities depending to the job. Then always you need to relate this to what you have to do, what you want to achieve, and this. So that's why you need to be in touch with injectors directly on the field.
Sure. Okay. So when I inject like the cracks in the bottom slab is somewhere between 50 centimeters, even up to 1 meter thickness of the concrete, and there is a crack. I love to use acrylic gel for this kind of application. And we use this acrylic gel where the part B is mainly water, because this material has the viscosity very low of around 7 millipascal seconds. Do you find this material good solution for the cracks in the concrete?
For cracks in concrete, yes, it's a good material, but you have to consider the size of the cracks, of course, because, okay, you mentioned the viscosity. Viscosity is one of the main advantage of this kind of chemicals. If you compare, it's not a competition, but I would say it's complementary. The PU and the acrylic.
And the acrylics.
Yeah, when you have the PU, you have higher viscosity. And PU can be used and have to be used for bigger cracks or bigger water flow to just stop it directly. Then for smaller cracks, for let's say deep infiltration, deep injection, or when the soil is really low permeability, you need to use acrylic because you will have the viscosity that's allow you to really enter the ground, really enter the cracks, and really do the job. So that's what can help you to choose the proper product.
Absolutely. The lower viscosity and the lower pressure I need to use on the pump to achieve the same amount of filling the crack. That is why I really like using this acrylic, and that is why I use this acrylic with water in the part B, not with these polymers and other stuff you mentioned before. So, but there is one thing that if we use the water part in this acrylic material, that if there is no water in the surrounding, in the ground, they say that this material can be dry, it's get less in volume, and it doesn't stick to the concrete anymore. So if there is another water coming, it can happen that this crack will leak once again. What's your answer to this statement? Because this is well known. I'm not sure if it's true, but this is well known disadvantages. People, say it here and there that this is not the best. Situation on the job site.
Yeah, I know this, and that's a point that quite often people are telling this because okay, that's true. First of this, if you consider a pure acrylic, you will have in dry condition, you will lose the water you bring from the beginning when you inject, and you will reduce the volume. Okay, so that's on pure acrylic. Then, as I told in the first question, you can formulate the acrylic or you can modify the acrylic. So when you formulate, you can reduce this drying and also the swelling rates. For instance, some of the acrylic can swell like 100%. Standard ones swell like 30%, but we can decrease this to 10% and even lower. And then it depends to the job you will have to achieve. So that's why, and that's also the mistake people are doing sometimes. They use one kind of products for all the job, and then they said, oh, it's not working here, but it's not working because from the beginning the product chosen was not a good one. To have really low shrinkage and really low swelling, low drying phase, you have also other alternative is a derivative of acrylic. It's metacrylic, and using this kind, you have nearly no drying. And okay, the big components, even if it's also modifying the viscosity, for instance, the emulsion, the latex emulsion, which is commonly used, you can also, by adding this, reduce the swelling in the drying stage. So okay, there is some movement in the gel due to humidity or dry condition, but you can really have good control on this also. But okay, you need in my speech generally, I used to say that it's a good technology, but you need to be well trained to use it.
Like everywhere, every single market has the same. It works, but you have to know how to use it.
But okay, that's okay. If we analyze a little bit the market, it's not the topic today, but PU are most commonly used because it's easy to use PU. You have B component and it's React, whatever you do. But okay, you cannot do everything with PU, so sometimes you need acryl, and if you know well the acryl, you will see that you have, in fact, plenty of possibility to and plenty of way to use the technology.
Sure, I agree on this. Absolutely. Okay, since I admit in the beginning that I run a service company in Warsaw, Poland, I noticed through these years that there are different kinds of acrylic gels. Some of them are better in the swelling. Some of them are have better adhesion to the concrete. Can you tell us a little bit which solution is better for injecting and sealing the expansion joints, because this is the most common application?
Okay, okay. Well, for expansion joints, normally, and what is most currently used is elastic and okay, little bit swelling, but not more than 30% in water. And time to time, they blend it with B parts, latex in the B parts. And these products have adhesion, good adhesion to the concrete due to some components we formulate in the resins. So that's what is commonly admitted for expansion joint, for instance.
Okay.
Then you have other kind of injection like typical cracks in parking lots or curtain. You make a membrane behind the wall. For this, you don't care about the sticking. You don't care about the big component. When you make a curtain, you just want to fill behind the wall with the products. And whatever, if it's sticky or not, you just fill, and you just have to make a complete membrane to have a complete coverage.
Okay.
So yeah.
Question. It's great that you mentioned this. The question is, if you know and if you can tell us how many kg we have to use per 1 square meter of the curtain to be more or less sure that this is, it's really filled and it's really watertight.
Well, okay.
I have my number. I'm just curious. What's your answer?
Okay. So first of all, I'm more on the as I introduced myself, on the chemical and the formulation and the selling development of this kind of products, not really 100% my time on the field injection.
Okay.
But this is a difficult question. This is a good question. Because it depends. First of all, it depends on what you have behind the wall. For instance, we had some job site in Mexico City where behind the wall you have clays. You have some in Spanish it's RCS clays. Yes. So the porosity of this is really low. So you have to put some pressure to put the material, and the quantity per square meters. Okay, I don't have any number to give here, to be honest, but compared to a rock or something more open as a ground behind wall, you will use really less. So in sand, for instance, I calculate the volume related to the porosity, which is between 35 to 45%. So you can have estimation like that, but to give you a number for just a wall per square meters, okay, I can't because it won't be a good advice to say that you will use, for instance, this quantity if you have a really open ground behind this.
Yeah, absolutely. Yeah. Okay.
So
well,
I'm sorry, I just can't answer this question.
No.
But I'm curious about your number. If you want to share, it's no problem.
So I say that it's somewhere between 35 and 40 kg.
Okay, and considering what kind of material you have behind the concrete structure.
So, in Poland, this is this kind of job sites. I mean, the curtains are being made in the old masonry walls in the old buildings, like even that were built even before the Second World War. And so the thickness of this wall is around 80 centimeters, sometimes even up to 1 meter. And then above this this wall, there is like this black soil. No clays, rather black soil. So we have to inject quite big amount of the resin to create this curtain between this last bricks and the soil. And the reaction time is more or less 1.5 minutes up to 2 minutes, so it's quite fast. Sometimes we even don't make the curtain itself, but we inject into the structure of this masonry, because if we have like 80 to 1 centimeters of it, so this is quite a big volume of the masonry, so it can be filled with this resin. And this is my favorite way of water tightening the structures, because the consumption of the resin is lower, and there is a better control over the material. We can easily see where is it coming inside the wall, because it goes through another packers in this whole area. So this is the way I do it. It's cheaper also for the investor, so they like it as well.
Just as a comparison, if you want to describe a case for a parking injection, parking lot injection, like also some kind of curtain behind the wall in some leaking parts, we have injected like just packers per packers, and we saw instead of the water, the coming back of the gel. And that's how most of the people consider that they well injected the area, is when they see the coming back of the gel. They imagine that it's reacted all the way along, so it's just coming back and the job is done.
I'm just working on a newsletter, and this is the one of the first newsletters, first email in this newsletter. And I'm trying to convince people to use injection packers, to install injection packer without already screwed nipple, because when it's installed without this, so whatever is happening in the crack or in the masonry during the injection, you will see the water coming out of it, or the resin coming out, so you will know where the resin is and what is your situation inside this. And it also lets you to minimize the pressure that is being built in the construction while injection is taking place. So yeah, this is one of the best ways to really understand what is going on in the concrete. We all know that the concrete is not, we can't see through it, but this really allows us to see a little bit what's inside. Okay, I have another question, because these acrylic gels are really tricky. We all know that we can, actually, maybe no, it's not that we all know. We are all told that we can set the reaction times of the gels, but why is it for? Why is it so important, and where it is really best place to make it as short as possible, or where, or vice versa? Can you give us a situation when we need it as long as possible?
Okay, well, it's always it's related to the job you have to achieve. If we consider a curtain injection, 1 minute, 2 minutes, like you said, it's okay, because you will make the membrane behind the wall. You don't have such distance to cover, so that's the most common case. For cracks injection, you need also this kind of setting time, more or less. Then if we consider other application, because I told you that you can play on the gel, you can play on the structure, you can have the hardness you want, you can have the softness you want. So we can go, and we are going to other application like soil consolidation, like there is much more application. We can get back on this, but if you consider a soil consolidation application, you will need to inject and to impregnate the soil, considering the porosity. So you will need to have much longer setting time to be sure that you have injected like a column of sand. I don't know if I'm clear on that.
Yeah.
That's for
I think
one
I
example
understand you.
when you need where you need to have a longer setting time. On the contrary, if you have a really high leakage, so you need a really short setting time, like 30 seconds or even 20 seconds, to avoid that the acrylic is going out by the flow rate. And
my maximum was 7 seconds. We add more salt than it was put in the technical data sheet, but it worked. 7 seconds.
Yeah, it works. Oh, well, there is also other kind of catalyst. I won't develop in this topic, but you have also a catalyst that you can use, and you have the reaction just like 1 second after. It's a immediate reaction. So you can have really, we can. Okay, no problem.
I have to try it. Okay, so reaction times depending on the what we are going to achieve on the job site. Very well. I mean, this is great because it's not that easy to set the reaction time when it comes to PU-based resins, and acrylic gels really gives us this. So this is a great advantage of this material. That's for sure. We mentioned this little bit, but if you could tell us the areas of application of gel, like where we can use it, and we know that this is a good solution for what's on the job.
Well, so today, if I have to describe the most common application, we will go from the expansion joint, curtain, cracks injection, tunneling, leaking, which is more or less related to cracks injection. You have applications that's soil consolidation, which are commonly known using the hard kind of acrylates or metacrylates. And then we develop other field of application like seismic insulation, like oil and gas application where you have some use of this material. So I would say that there is the civil engineering application, but inside the civil we can always extend and improve the technology, and then there is some kind of new application like the oil and gas where the product are considered to for some very specific application, but when you touch to oil and gas, you touch volumes. So that's a point.
I was just, my imagination started to work when you mentioned the
Well,
oil or gas well.
today
So
oil and gas slow down a little bit, but it's just a matter of time and due to the situation.
we will come back to this during this conversation if you have find some time, a little bit, because I have this question that is also discussed on the job sites, and many engineers simply don't allow me to inject acrylic gel into the cracks. I mentioned in the beginning of the conversation that I like to use this material for crack injection, especially when when the concrete slab is between 50 to 1 meter in thickness. Why, you may ask? So they don't allow me because they are afraid of the salt in the component B. They are afraid of the, that there will be a corrosion in the concrete, and especially in the steel bars. So is it harmful to steel if we use this material?
If you consider the salts just as the salts, yes, it's corrosive. But when you inject, what you are doing, you inject the salts in the liquid, in water, and the salts will react and will be used to initiate the polymerization. So then you have the polymer with the initiator stuck inside, and with no more corrosive effect on the steel. So the only material you can have corrosion on is the pumps and the packers.
Okay.
Because
sounds familiar.
You are in contact with the salts directly with those equipments, but then once in the ground, as it's polymerized, you have no risk really. So I would say it's just some people are also afraid about using monomer because okay, the product itself, it's monomer. In the past, maybe let's say 10 years ago, they use acrylamide. No, acrylamide is forbidden. Okay, you probably heard about this. It's forbidden because acrylamide is highly toxic. But when you make the gel using acrylamide, you make a polyacrylamide polymer, which is not toxic, and the polymer itself is not toxic. For instance, this kind of polymer are used for water treatment application. So well, they are probably afraid a little bit because they are not knowing exactly what happened with the product after reacting.
Yeah, I was told that acrylic gels are very good for these expansion joints because expansion joints are only concrete. I mean, left and the right side of the expansion joint is the concrete wall, period. So we inject the resin between two concrete walls. That's it, right? No risk of any rebars, being there naked without any passive. So that's it. And this is one question. But when you said this, that the only time that we have the salt is in the pump, and to be even more exact, in the part B, because this 2K pump transports this resin separately until it's mixed in the mixing head just before it's injected. So I reminded myself when I bought a pump in 2013, and a year and a half later, we found that the component B really destroyed the injection hose of this part B, because it was meant for the PU resins, not for the acrylics. So yeah, I was given another set of hoses, this time for acrylics, because the corrosion really destroyed this. Within a year and maybe a year and a half. So yeah, the corrosion will take place. I can say that I've seen it on my pump in the house, but well, not for the rebars. 100%, right? What? But there is a condition. We have to really mix the component A and component B very carefully. So there is no salt being pumped into this crack without component B. So this is also the pump has to work very properly. Yeah. Okay. We are discussing mainly acrylic gel that are elastic for water tightening, mainly expansion joint, as you explained. But I know that there are acrylic gels that are also rigid. They are not that well known on the market. So do you know how we can use this kind of materials and why they are not so popular?
Okay, there is probably different reason like why they are not popular. The first reason could be for the very hard material, the price could be one of the reason, because okay, you have different kind of monomer inside. You have more expensive products in the formulation, so final price are a little bit more expensive. Let's say that. So that's the first point why they are not commonly used. But okay, also for let's say 80% of the jobs done by acrylic, you don't need such a hard gel. So, and when you did some hard gel, as we explained before, PU are most popular, and you can use the two component PU also to have hard stuff. So that can probably explain why they are not so popular. But okay, we have some acrylic, we have some metacrylic, and the one made with metacrylic are one of the more hard in the market. If we focus on acrylochemistry, I mean. So that's a part of the answer for the question you asked. Then maybe also simply because PU are easier to use, as we said before. So that could be all this reason.
I think there is also another one that, for example, when the goal is to inject into the ground to stabilize it, and then we simply choose the cementitious materials because they are even cheaper than the PU-based resins, let alone this acrylic gel. And then if we use like 500 bars and we have this rotation mixing device in the ground that mixes the ground with the cementitious material, and then there is no way not to make this ground, stabilized. So this is it, and this is of course cheaper because this is the cement is way cheaper than the any resin. That's it. This is well-known technology.
Yeah, could be, but cement, when you put cement, you modify the viscosity. So, okay, if I've got some job sites, soil consolidation job or mining job where you need really to inject really low permeability ground, and they have no choice to use really highly structured and formulated acrylic, yeah, to obtain the hardness.
I have a question concerning this because some time ago I had an idea to put another solution, meaning inject the resin into the ground, but I was told that I have no papers saying what is this, how do the ground works with resin, like we know how the ground works with the concrete. But it was like 5 years ago, maybe even 7 years, something like that. So a long time ago. Do we know at the moment, is this any calculation being done? That it's easier to calculate, like when the client asks me how much resin should I inject over there to stop this building falling, that I will be able to calculate and use PU or acrylic for that reason. Do we have any knowledge on this?
You mean to bring some structural properties back using acrylic?
Yeah.
Okay.
Can we calculate how much and how much resin on what depth into the ground and where, and to give this paper to our client and say, look, if we do this step by step like that, so these are the whole calculations. It is so you are on the safe side.
Well, to be honest with you, I never recommend to use acrylic to give some really structural properties back to some building or some cement. We have made tests for sure. We have made tests injecting some kind of some block of cement. We put pressure on this, we crack it, and then we re-inject the cement just to see how much structural properties we can bring back, and we reach like 45% of the properties. But today it's just a project related to some study in seismic and in concrete properties itself. But it's not sold today. Sorry, we have been cut. It's not sold today really as a solution for restoring let's say the properties of cement, because it's very too specialized application, and it's it's today for me personally, I mean, it has not been studied, and it's too far from purely injection and injection job or some kind of soil consolidation, injecting a block of sands or block of ground. So never really studied this topic, to be honest.
Okay, I understand you. Okay, so you mentioned before a little bit on this, and I said that we will come back to this topic in the end of the conversation. So the question is, what are the other areas of application? You mentioned the seismic areas. Can you dive a little bit more into this topic, because I find it very interesting, I must admit.
Yes, I can describe a little bit the project. So it started like 6 or 7 years ago with some requests from Italy. After some kind of problem or issues they have with earthquake, to consider the products to insulate. First of all, it was insulating building, And okay, so we work with some lab and measuring the properties, measuring the compressive strength, measuring all the characteristic of the gel. And then we also consider the possibility to use the gel as a dampening system to avoid, let's say, the building displacements during earthquake.
Okay.
So this was studied, and then we let this on the side. And well, very recently we had some requests in some country really subject to seismic problem. It's like Mexico. And we restart the project. We restart all the study, and for this study, we also that's from where I have the data, studied the properties we can get back on the concrete, where I mentioned 45%, and so we will start all these topics. And today we are studying this. How we can dampen the building effect, how much you need to inject, what is the cost, what is every parameters. I know it sounds like crazy, but okay. These people really look for a good solution to the big problem, because they expect a big one. They don't know when, they don't know how, but they expect big one.
Yeah.
So that's today we are it's a 2 years project, 2 or 3 years project. So we study it, then we will see how we can validate. We have the good labs, we have the good relation, and now it's just a matter of really getting all the data we need to convince people to make a big scale trial.
Wow, that's really sounds fantastic. If you really able to help these people and their building to stay even during the seismic and the earthquakes. You also mentioned the oil and gas wells. What are the amounts of the resin that you need to pump into this to create the plug?
Well, you commonly inject like 7 to 10 stones per well in the
7
field.
to 10?
Yeah, so as there is some let's say 1,000 or 100 or 1,000 well, it's relatively good and big volumes. The product used in this application are combined to other technology, but okay, they have a use of this kind of technology. So really, as I told you, the property of acrylates can be bring to a lot of different and various application and sectors. So that's
do they, I mean, 7 to 10 tons of the resin per one well, that's enormous amount of material. Saying me, who uses hundreds, not thousands of kg per one, underground parking place, where we inject only into the expansion joint, not into the well. So this is mind-blowing for me. What kind of pump do they use? The same pump as I do, 2K piston pump?
No, it's not. It's no more than 2K. For this, we are in touch with some pump manufacturer, and they build some specific pumps to be able to bring the product exactly where we need to bring it, and also to blend it not so far from the point, because obviously you have the temperature problems, you have the delaying problems, so you have to consider the whole system and to bring the machinery related to this. But okay, as we mentioned, for this application, as soon as you can have some bring or add some added value for this kind of application, you will use it. So you interest the guys. So
okay. I would love to see the pump, pumping this huge amounts of resin somewhere. You don't know where. That would be great. Okay, so this is it. We agreed to cover these topics. From my point of view, most interesting for the beginning, because I'm really sure that we will have another opportunities to meet once again for another episode of the Concrete Injection Made Easy podcast. As we all know, not all of the topics we covered are concrete injections, because if we discuss the ground injection, this is obviously not concrete, but still injection and still water jobs, still job sites to be done worldwide. And very interesting for me to enter this new areas of running my own business. Okay, do you have any question for our listeners to ask? Like, what would you like to, to ask them?
Yeah, I would say that it's a good start we've made today, and of course, if there is specific request or specific demands following this, we can probably adapt some kind of in different interview to their questions to be more in details on different parts, because we have tried to cover, let's say, briefly, because we have briefly covered different topics.
Yeah.
So it's a wide range of application, a wide range of products, wide range of use. So if they have
I just wanted to choose these questions that are very commonly asked. Some doubts about this corrosion, the salt, the time reaction, and so on. So we have done this. You said a little bit in the beginning what's the acrylic gel in general. That's for us who are really interested a little bit more in this. And now we are waiting for questions from our listeners. Yeah.
One last thing. Yeah, one question we probably need to deal with would be, okay, it's a complicated topic because there is different opinion on this. It's the aging of the gel. Once it's injected in the ground, how long does it last? Blah blah blah. All this kind of topics. Okay, so far when we have made some accelerated aging study in the lab, we obtain, let's say, shelf life more than 50 years in
50 years.
it's lab condition. But in reality, when you consider the job we have done like 25 years ago, okay, still nothing to complain using the acrylic. So I would say that today the minimum in the application is 25. Then as the technology is relatively recent, the new version of acrylic and all this stuff, it's recent. In the past, it was, as I told you, acrylamide, which is not forbidden, and acrylamide, they have also some like 50 years jobs done, and nothing has moved. So sometimes people are complaining about relatively low aging of this product. Well, today I've got no bad feedback from the ground from job we have done 25 years ago. So that could be a question from the people, I guess.
Great. I didn't think of this question, but it's asked anyway. Thank you very much.
Thank you
for that. I just wanted to say that when I heard on my metro project a couple of years ago that the metro station is designed to last for 100 years, I was in shock, because only 100 years for the metro station that it's in the underground of the downtown or in the center of the huge city. I would say at least 300 years. So if you say that the acrylic gel can last over 50 years and 25 for sure, because we have all the application that last for that and still work, so I can easily use this material. I'm not worried about any complaint and so on and so on. Thanks for this conversation.
Okay, thank you for your time.
Thanks for finding the time for me and for our listeners. Now we are waiting for some questions. I hope that people will be interested in the topic, and if there are questions, then we will find each other once again to answer them. Yeah, that's it.
Okay, sounds good. Thanks.
Thank you very much, and all the best. Bye-bye.
Bye.
Brice discussed the use of acrylic gels for leak sealing concrete in curtain injection procedures, and even to make structures more resistant to earthquakes. I'm sure you know how to use acrylic gels to take your concrete injection business to the next level. Thanks for listening, and I hope you tune in next time.